Okay, for section 10.3 we're going to be talking about polygons and perimeter. Last time we talked about the triangle being closed shape. A polygon, the definition is any closed shape in the plane formed of 3 or more line segments that intersect only at their endpoints. We'll see some examples here in just a minute. But ultimately there's a couple of other things here. A regular polygon is one that has all side lengths and all angles the same measure. And the perimeter of a polygon is just the sum of the lengths of its sides. Okay, or also we could consider it the distance around the outside. So let's take a look at a couple pictures here of some polygons. Okay, some typical ones that we see here that we learned about in geometry. Of course, we know a triangle has 3 sides. Okay, a quadrilateral, even though this is drawn like a square, it doesn't necessarily have to look like a square. It could be a rectangle also, or other shapes, as long as they have 4 sides. It's considered a quadrilateral. Of course, we have a pentagon, which is 5 sides. A hexagon is 6. Heptagon is 7. Octagon is 8. Okay. So different types of quadrilaterals we're going to look at next. Quadrilaterals are what we use. Triangles and quadrilaterals probably the most in geometry. But there's some characteristics of some special ones here. This is a parallelogram. Okay, both pairs of opposite sides are parallel to each other. Opposite angles are congruent, which means they have the same measure. Okay, and not only are the sides parallel to each other, but they're also equal in length. So there's lots of properties that are going to be true when we have a parallelogram. If we have a rhombus, the only thing true about a rhombus for sure is that all sides have equal length. Okay. If we have a rectangle, opposite sides are equal length. Okay. Opposite sides on both directions, and also all the angles are right angles. And when we have a square, all right angles and all 4 sides equal. And then when we have a quadrilateral, we have exactly 1 pair of parallel sides, okay, namely these 2, if you will. Okay. So, problem here next is we're given a shape here that tells us the fencing costs $5.25 per foot, and we want to find the cost to enclose the field with fencing. So remember, the perimeter is what we're after here, because the fence is going to go around the outside of this shape. And if we're 42 here, and we're 42 here, and we're 28 here, okay, we can certainly calculate the perimeter. Okay, we do have a perimeter formula, okay, for a rectangle. Okay. And if we do 2 times the length, 2 times the width, we turn out to be 140 yards. Now the biggest issue we have here, though, is that the price is in per foot. Okay, so we can't multiply a number of yards by something per foot. So just like we did in chapter 9, okay, we could change this to feet first. Get yards here and feet here. We know there's 3 feet and 1 yard. So if we do the multiplication on that, we're going to wind up with 420 feet of fencing. And then if we multiply that by $5.25 per foot, okay, the feet will cancel out and leave us with dollars. And ultimately, if we multiply 420 times 525, okay, we wind up with a final price of $22.05. Okay, so we'll change the yards to feet. Okay, and then once we have the feet, we can multiply by dollars per foot. And once again, just like I illustrated in the previous slide, those 2 will cancel, leaving us with the only unit being dollars. And that'll give us the total cost to fence that particular yard. Okay. There is a formula also that we're going to use here that gives us the sum of the measures of the angles of any polygon with n sides. Okay, and that formula is, remember, that's equals, okay, n minus 2 times 180. So we're going to find the sum of the measures of the angles of an octagon. Okay, if it's an octagon, then n would equal 8, of course. And if we use the formula, we're going to go 8 minus 2 times 180, and we're going to get 1080. So if I drew an octagon, okay, which if I go back a couple slides, so here's an octagon. If I were to take all 8 angles and add them all together, okay, they would equal 1080. Okay, so each of these different polygons has a different total of other angles. Okay, and the total is found by using the formula n minus 2 times 180, where n is the number of sides. Okay. That is it for section 10.3.